Hello students, today we'll see grade 9 physics unit 3, that's force and Newton's law of motion. And don't forget to subscribe, like and share the videos, and if you have questions and comment, write us on comment.
Okay, hello students, my name is Roskazao. I'm your physics teacher. Today we'll see grade 9 physics unit 3, that's about force and Newton's law of motion. First, let us define and see force in nature. When we say force, force is an ability to push or to pull on something, or a body is simply a force. Therefore, force is a push or a pull action of a body on other body is a force. When you push or a pull your book across a desk, or when you push or pull applied a book or called a force. These are some examples. And these forces are deeply in physics. They are classified into four basic groups. The first one is gravitational force. When we say gravitational force, a force attractive gravitational force is, as you know, it's what? Attractive force. And this gravitational force is act between two masses, between two any masses. And the second one is electromagnetic force. This electromagnetic force is a force that holds what? Atoms and molecules together, or dealing with charged objects, atomic interaction, whenever objects come into contact. And the third one is strong nuclear force, and the fourth one is weak nuclear force. These two forces are forces in an atom, and strong nuclear force is a force that bind what? Proton and neutron, and weak nuclear force is a force that causes atom to break apart. Thus, this force is what? Responsible for radioactive decay. In this case, there are different examples of a force. Friction is the first, weight, gravitational force, buoyant force, thrust, contact force, magnetic attraction or repulsion, electromagnetic attraction or repulsion, tension, and so on. We have so many types of forces. And we can also classify forces into two depending on the action. The first one is contact, and the second one is non-contact force. These contact forces are a force when the force exerting object and the force applied object is in contact before the force is applied. For example, when you kick a ball, before the ball is kicked, your leg and the ball must be in contact. After that, the force is exerted. Such types of force is contact force. And the second one is non-contact. Non-contact force is a force that exerts a push or a pull effect on a body as a distance, touching a body without touching each other is non-contact force. An example of this non-contact force is gravitational force, magnetic force, electrostatic force, and etc. There are so many. And the other thing is effects of forces. Force have basic effects. The first one is change the direction of a motion, and it may also change the state of motion of an object. It may also change the state of the motion. That means either increase velocity or decrease velocity of an object, or it may change an object to move with a velocity from rest. That means it changes what? The motion of the object. And also it has another effect, which can be force is used to deform, or force can deform the shape of an object. When you exert two forces, for example, if you have some object, let us say this one is a balloon, and if you exert a force in this direction and in this direction, the shape of this balloon is changed. It may just like this pattern. Therefore, the shape of this balloon is changed because of these forces. Therefore, force can deform the shape of a body. The other thing is Newton's law of motion, and from this, first let us see Newton's first law. Newton's first law is named as the law of inertia, and Newton's first law states that if the body is at rest, it remains at rest. If the body is in motion, it keeps its motion with constant speed in a straight line, unless an external force is acted upon. This indicates that if the net force acting on the body is equivalent to 0, the state of the motion remains the same. If the body is in motion, it moves its motion with constant velocity. If the body is at rest, it remains at rest if the net force acting on the body is 0. This one is Newton's first law. The other thing is mass and inertia. Mass and inertia. Mass and inertia. Inertia is what? The measure of the resistance of a body. Inertia is the measure of the resistance of a body to any change of what? Its state of motion. Newton's first law, sometimes called the law of what? Inertia. The law of inertia. A body is said to have large inertia if it is hard to change its state of motion. If it is a state of rest or its state of motion, if you are difficult to change its state of motion, that material or that object has a large inertia. The other thing is Huxley's law. Hooks said that in any elastic materials, the extension x of the material is directly proportional to what? The force applied until it reaches the elastic limit. Above the elastic limit, this proportionality fails. And then the force F is equivalent to, by cancelling this proportionality, he makes equal by adding some constant K times X. And this is, F is what? The applied force, K is the spring constant, and X is the extension. Therefore, by using this equation, you can calculate the force on spring where it's stretched by applying some force. And also, if you are asked to calculate spring constant, K is equal to F over X, or if you are asked to determine the extension X is equal to F over what? Spring constant K. You can use either of these. The other thing is spring balance. Spring balances are used or designed by using a spring by using this Hooke's law proportionality. For example, if a material expands or extension is 3 cm for 1 Newton of mass, this implies that the spring constant K is equal to 100. Let us say it is 2 cm. Therefore 150. Let us say the spring constant is 50 Newton per meter. This indicates that for each 1 meter extension, the spring will needs 15 Newton of force. If we multiply both by 100, because this one is meter, therefore if you change to centimeter, 50 Newton divided by what? 100 centimeter. And then finally 0 is cancelled, 5 over 10. That means it's what? 0.5 Newton per centimeter. This indicates that for 1 centimeter extension, we need what? 0.5 Newton. And by using this, the spring balance is designed. Spring balances are just like this. The design of the spring balance are just like this, and they have some scale at this point, and this scale is designed by this spring constant relation. And then if you connect a load to this spring, the load, depending on the spring constant, for example 0.5 Newton per centimeter, 0.5 Newton means 0.05 kilogram of an object extends how much? 1 centimeter. Therefore, by using this relation, they can measure the mass of a material by using spring balance. Therefore, spring balances are an instrument which used to measure weight of an object by using the relation between extension and force from Hooke's law. The other thing is elastic deformation, elastic limit, and plastic deformation. When we say elastic deformation, is a deformation where an applied force is proportional to what? the extension and spring returns to its original position. After you connect a load, when the load is removed, if the spring or the material is back to its original position, the deformation type is what? Elastic. And the elastic limit is a point up to which the spring stretches elastically, beyond which this elastic limit, the material is changed to plastic deformation. Plastic deformation. ለምሳሌ ስፕሪንግ እንደዚህ በጎትቱት የሆነ ቦታ ድረስ ከጎትታችሁ በኋላ ሲለቁት ይመለሳል። የሚመለስ ከሆነ ወደ ኦሪጂናሉ ኤላስቲክ ዲፎርሜሽን ነው። ኤላስቲክ ሊሚት የምንለው ደግሞ በጣም ስጎትቱት ይዘረጋል ወይንም የሚመለስበት ወደ ኤላስቲክ ዲፎርሜሽን ወይንም ወደ መጀመሪያ ኦሪጂናሉ የሚመለስበት የመጨረሻ ሊሚቱ ማለት ነው። Therefore, plastic deformation is when a force is applied to a spring and when the force is removed, if the material is not returned to its original position, the deformation type is what? Plastic deformation. Plastic deformation. Okay. The other thing is Newton's second law. Newton's second law is defined in so many manners, but Newton's second law of motion describes between two objects, that is mass and acceleration, always if the net force acting on the object is different from zero. That means if there is an external force or net force on an object, the object will what? Accelerate. And the acceleration of this object is to the direction of the net force. This is Newton's second law. And this F net, finally, he states, or he gives us an equation, then F net is equal to mass times acceleration. And the direction of this acceleration is to the direction of what? The net force. When we say net force, the sum of all forces acting on the body. Here, as you see, forces are unbalanced. That means there is an external force. Because of this external force, there is what? An acceleration. The acceleration depends inversely up to the object's mass. And the acceleration has a direct relation with what? The net force. As you see, from this A is equal to F net over M. This acceleration has an inverse relation with the mass, but it has a direct relation with the net force. Let us see two examples. Determine the acceleration that results when 12 Newton force is applied to a 3 kilogram object and then 6 kilogram object. First, for the 3 kilogram object, if the force is given, and for this, if you are asked to determine acceleration, F over M, and F is 12 divided by what? 3, it becomes 4 meter per second square. And for the 6 kilogram, 12 over 6, it's what? 2 meter per second square. And a net force of 50 Newton is exerted on an encyclopedia to cause it accelerate at a rate of how much? 5 meter per second square. Determine the mass of encyclopedia. Therefore, M from Newton's second law, M becomes what? F net over acceleration A. And the net force is 50 divided by what? 5. It becomes 3 kilogram. This is how we can use Newton's second law. Okay, let us see balanced force. When we say balanced force, it indicates that when we sum up the forces acting on that body, if it becomes 0, we can say the forces are what? Balanced. But if it is different from 0, the sum of all forces acting on that body, if it is different from 0, the forces are what? Unbalanced. Therefore, when we say balanced force, the force acting on that body must sum to 0. If it is unbalanced, the net force acting on that body is different from 0. It indicates that. The other thing is mass and weight. When we say mass is what? A measure of how matter sometimes contains. Why? Weight of measurement of the pulley gravity on an object. And mass is measured by using what? Balance, but comparing to a known amount of matter to unknown amount of matter, while weight is measured in what? On scale. And in addition, mass is scalar quantity, and weight is what? A vector quantity. And weight is again vector, and what? It's a force. Therefore, these are some differences of weight and weight and mass. The other thing is frictional force. Friction is a force resisting what? The relative motion of solid surface, floor layers and materials, and so on. And this frictional force is always acts in opposite direction to what? The motion of the object. And frictional force is always applied opposing to the motion of the object, and frictional force always depends on two things. The first one is roughness of the surface in contact. For example, these two objects are this surface and this object are in contact at this position. The roughness of the contact determines the frictional force. If the contact is more rough, the frictional force is high. If the contact is less rough, the frictional force is what? Small. And rough surface have large friction than smooth surface, as I said. And the normal force N, the force which is perpendicular to what? The surface of contact. And when we see an inclined plane, the frictional force is two types. We have static friction and kinetic friction. For static friction, if you are asked to determine the frictional force of static friction, you can use coefficient of static friction times what? Normal force. And this normal force is depend on the motion of the object. For example, for this surface, this angle is theta, and here we have what? Weight, and here is weight times what? Cos theta, and the normal force N in this case is equivalent to what? Weight times cos theta for an inclined plane. Therefore, it depends on the type of motion. And this static friction has a coefficient, and this coefficient is coefficient of static friction, mu s, and this mu s is always between 0 and 1. And we have seen also about static. The second one is kinetic friction. To calculate the kinetic friction, Fk is equal to what? Mu k times normal force. The normal force is similar to the static one, as we see in an inclined plane. And always you must take care when you use this normal force. In other way, the maximum value of static friction is limiting friction. Limiting friction is the maximum value of static friction. When we say static friction is a frictional force when an object is stationary. The frictional force attained by an object when it is what? Stationary. Stationary is frictional force which is static. Therefore, from the name, static means at rest. Therefore, when the body is at rest, it attains or it have a static friction, and the maximum value of this static friction is named as limiting friction. And kinetic friction is a frictional force when an object is in motion. A frictional force attained by an object when it is in motion. And when you compare these two, always static friction is greater than kinetic friction. Always. And also, when you compare the coefficient also, coefficient of static is greater than coefficient of what? Kinetic. This is true. Okay. The other thing is inclined plane. We have seen about inclined plane property. We have seen also, you must see this by yourself. Let us see Newton's third law. When we see Newton's third law, Sir Isaac Newton states or explains Newton's third law as action and reaction force. When we say action and reaction force, if we have two body A and body B, if body A exerts a force on body B will exert an equal amount of force on body A in opposite direction. This is Newton's third law. Therefore, for any action force, there is a reaction force. Because of this, it states that if body A exerts a force on body B will exert an equal amount of force on body A in opposite direction. And this is Newton's third law. It's action and reaction force. Action and reaction force. The action force is the force exerted by body A, and the reaction force is the force exerted by body B. And the forces are equivalent, and they are acting in opposite direction. And the force exerted by body A is FA, and the force exerted by body B is what? FB. And from this relation, since they are equal and opposite, FA is equivalent to minus of what? FB. This one is the action force, and this one is the reaction force. This one is Newton's third law. Examples of Newton's third law: of the chair pushing up against you, the force acting on you as you sit in your chair are just one example of Newton's third law, which state that you ever action force, there is what? An equal and opposite reaction force. The other thing is conservation of linear momentum. When we say conservation, unchanged or constant. Therefore, linear momentum is calculated by using mv, and when it is conserved, if the net force F net is equivalent to 0, the net force acting on a body is equivalent to 0, always the changing momentum of an object is equivalent to 0. This implies that momentum initial and momentum final is what? Equivalent. Or momentum after and before is what? Equivalent. In the absence of external force. That means momentum before collision and momentum after collision is what? Similar. And this one is the conservation of linear momentum. Therefore, linear momentum is conserved in the absence of external force. And as you see, momentum is dependent on two factors, that is mass and velocity. There are two factors that makes an object harder to stop, that is mass and velocity. Therefore, the greater the mass, the harder to stop, and the faster the object, it's harder to stop. Momentum measures how it's hard to stop an object. Is measured by momentum. Okay, linear momentum is defined as a product of what? An object, that is mass and velocity. Therefore, momentum is equal to mass times velocity, and momentum is a vector quantity. And if I ask, for example, a ball of mass 4 kg falls into floor, it's land with a speed of this much, and it bounces off with the same speed. Calculate the changing momentum of the ball. First, you are asked to determine momentum initial and then momentum final. First, 4 kg mass, and this speed is initial momentum. Momentum initial is equal to mass times velocity initial, and this one is equal to mass is 4, initial momentum is 6, finally it is what? It is 24 kg meter per second. This one is the initial one, and the final one is it bounces off with the same speed, with similar speed, but the speed, since it bounces, it's what? In opposite direction. Therefore, momentum initial, momentum final is equal to what? Mass times v final, and mass is what? 4 times what? 6, it's what? 24 kg meter per second, and change momentum is equal to what? Momentum final minus momentum initial. Therefore, here we make negative for the final momentum, because since it bounces off, the velocity is negative in opposite direction too, because initially the ball is moving to this direction, after it bounces it moves to this direction. Therefore, the speed is for this, it is positive 6, for this one it's negative 6. Therefore, this answer becomes minus. Therefore, P final is 24 minus negative 24. Finally, we can get how much? 48 kg meter per second. Therefore, by using this technique, you can determine conservation or the changing momentum of an object. Okay, we have seen about conservation of linear momentum before. Therefore, let us jump that and let us see two examples. Calculate the momentum of mass of 1,200 kg traveling with a velocity of how much? 3 meters per second, and that momentum is equal to mass times velocity. The mass is this much and the velocity is what? 3, and the product of the two gives us the momentum, which is what? 3,600 kg per meter per second. The other thing is a bullet of mass 0.01 kilogram is fired into a sandbag of this much, hanging from a tree the sandbag with a bullet embedded into it swings away at what? 10 meters per second. Find the momentum after collision, P final. Momentum after collision is equivalent to momentum mass of the bullet. That means it is first. Momentum after the collision is equivalent to momentum of the bullet plus what? Momentum of the sandbag. And momentum of the bullet is mass of the bullet times what? Velocity of the bullet final plus mass of the sandbag times velocity of the sandbag final. After it's fired, the sandbag and the bullet are stick together and move with each other. That means velocity of the sandbag and the bullet after collision is what? Equivalent. Therefore, B final is equal to mass of the bullet plus velocity of the bullet times what? V. And mass of the bullet and velocity of the bullet is, when you sum up, you can get what? 5 times 10 meters per second. The final velocity 10 meters per second. Then finally 50 kilogram meter per second is 50 kilogram meter per second is the momentum after collision. Here, as you get, okay, this one is 0.5, sorry, it becomes what? 5 kilogram meter per second is the final momentum. The momentum before collision. Before collision, since there is no an external force acting on an object, before collision and after collision is similar. Therefore, momentum initial is similar to momentum final. Therefore, it's what? 5 kilogram meter per second. And if you are asked to calculate, see the velocity of the bullet. You must use momentum before collision plus initially the sandbag is what? Stationary. The velocity of the sandbag is 0. Therefore, because of this, mass of the sandbag, the mass of the bullet, velocity of the bullet plus mass of the sandbag times velocity of the sandbag, and this one becomes 0 because initially the sandbag is at rest. And then mass of the bullet times velocity of the bullet is equal to mass of the bullet times velocity of the bullet is equal to what? Initial momentum. The initial momentum is 5. And from this, mass of the bullet over mass of the bullet. And this one cancel out. And finally, velocity of the bullet is equal to 5 over mass of the bullet is 0.01. And when you divide this, you can get 50 meters per second. 50 meters per second. Okay, question number 3. Two billiards balls rolls towards each other. They each have mass of 0.3 kilogram. Ball 1 is moving at this velocity and right, while ball 2 is moving at 1 meter per second. To the left, calculate the momentum of the system. That means we must find the momentum of the two balls separately and then we can add them. Momentum 1 is equal to m1 v1 times m2 v2. This one is v2. And the product of these two and these two gives us what? This much. Since they are moving in opposite direction, one of the two becomes negative. The other thing is collision. We have two types of collision, elastic and inelastic collision. In both cases, in the absence of external force, change in momentum of the system is constant or conserved. In both cases, in elastic as well as in elastic collision. In this collision as well as in this collision, the momentum of the system is conserved in the absence of external force. But if it is elastic collision, again, it's not only the linear momentum is conserved, the kinetic energy of the system is also conserved. That means kinetic energy initial and kinetic energy final is what? Equivalent for elastic collision. If the collision is in elastic collision, change in kinetic energy of the system is not conserved. That means the initial and the final is not equivalent. Always kinetic energy initial is greater than kinetic energy final, because always there is what? Loss of energy. And the final point, the last point for this unit, is first condition of equilibrium. First condition of equilibrium state that always the summation of forces acting on that body is must sum to what? Zero. If this happens, the object is in equilibrium. We can say the object is in equilibrium. Therefore, to be in equilibrium, the summation of all forces acting on that body must come to 0. When we say this, if we have horizontal and vertical component separately, the summation of forces in the x-axis is equal to 0, and the summation of forces in the y-axis is equal to 0. If these two becomes 0, we can say the object is in equilibrium. If one of the two is not equivalent to 0, the object will not in equilibrium. This is all about Unit 3, that is force and Newton's law of motion. Until next time.